Hi students, a warm welcome to KSN Classes. Today we will discuss Leibniz's theorem in definite integrals. Leibniz's theorem is the differentiation of the given function under the integral sign. That means I'll write the statement here. Ux comma Vx are differentiable functions and fx is integrable. Then d by dx of integral ux vx ft dt. That I mean to say the derivative of this function. So the differentiation of the given function under the integral sign or differentiation under the integral sign. The Leibniz rule is nothing but the differentiation under the integral sign. This can be considered as f of upper limit vx into derivative of the upper limit v dash x minus f of lower limit ux into derivative of u dash x. This is the formula for the Leibniz rule. There are several formulas. This is one of the formulae. Okay, so ux and vx are two differentiable functions and fx is integrable. Then d by dx of integral ux to vx ft dt is equal to f of vx, that is f of upper limit, into derivative of upper limit v dash x minus f of ux into v dash x. I will do some problems under this. I will take the first problem. The problem is y of x is equal to integral pi square by 16 to x square into cos x, pi square by 16 to x square cos x into cos root theta by 1 plus sin square root theta d theta. Then y dash pi by pi. This is a integer type question. Now here y dash pi is required. That means y dash x at x is equal to pi. That means first of all we have to get the value of y dash x. Later we will substitute pi in place of x. So you have to differentiate it. It implies yx is equal to, here x and theta both are variables, but you are integrating with respect to theta. Therefore you have to pull this cos x out, because when you are integrating this with respect to theta, this cos x can be pulled out. Integral pi square by 16 to x square cos root theta by 1 plus sin square root theta d theta. This is the problem. So I have written this problem like this. Now there are two functions. One is cos x and one is integral pi square by 16 to x square cos root theta by 1 plus sin square root theta d theta. Now I will differentiate y dash x. To differentiate this function under the integral sign, I will apply the Leibniz rule. But there being two functions, I will apply the product rule of differentiation. Cos x u into derivative of v, the differentiation of this. This is cos of root x square upper limit by 1 plus sin square root x square into derivative of x square 2x minus the cos of this one root pi square by 16. This being a constant when you consider its derivative, because f of vx into v dash x minus f of ux into u dash x, the derivative of the, so this will become 0 plus now the derivative of this minus sin x into, it will be as it is, pi square by 16 to x square cos root theta by 1 plus sin square root theta d theta. So now Now I'll consider y dash pi. Y dash pi. This is cos x. Into this will become 0, so you can do root x square into cos x into 2x by 1 plus sin square x at pi minus, this is 0, this is sin pi, this is sin pi. So sin pi into this is integral pi square by 16 to pi square cos root theta by 1 plus sin square root theta d theta. Here also you can directly write x is equal to pi here, cos pi into 2 pi into 1 plus sin square pi. You can write directly like this. Now here it is not necessary to find out its integral now, because sin pi is 0, it will become 0. Now here cos square pi means y dash pi is equal to cos square pi. Cos pi is minus 1. Cos square pi 1 into 2 pi. Sin pi is 0. So this is 1 plus 0. This completely becomes 0. Therefore this is y dash pi equal to pi. We are asked to find out y dash pi by pi is equal to 2. This is the result. The second problem. I'll consider the second problem. Fx is equal to integral 0 to x e power t into sin x minus t dt. X minus t dt. Then find the number of integers in the range of f double dash x minus f of x. F double dash x minus f of x. Now this is the function. Now directly if you differentiate, here there are two variables x and t. If you differentiate and if you apply the Leibniz's rule, it will become integral 0 to x e power t sin x minus t dt. If you directly apply the Leibniz's rule, it will become integral ux to vx ft dt. It will become e power x into sin t minus t. X minus x. This will become 0, but it is not correct because both are variables, but you are integrating with respect to t. So this is not right. So I will apply one formula. Integral 0 to a fx dx is equal to integral 0 to a f of a minus x dx. Now here this can be written as integral 0 to x e to the power of x minus t to sin x minus t dt. Now this can be written as integral 0 to x e to the power of x into e to the power of minus t into sin t dt. X gets cancelled. Now here both x and t are variables, but you are integrating with respect to t. So this can be written as e to the power of x into integral 0 to x e power minus t sin t dt. Now I will differentiate. F dash x is equal to, again here I will apply the product rule. E to the power of x into derivative of this. Derivative of this is e power minus x into sin x into derivative of x is 1 minus, this is of course the derivative of 0 being 0, you can directly write it, plus the derivative of e power x into integral 0 to x e power minus t sin t dt. Now I can write, this is a formula used here. This I can write as f dash x is equal to e power x and e power minus x gets cancelled. This is sin x. This is sin x. Of course, this is 0. This is e power x into integral 0 to x e power minus t sin t dt. This is f of x plus f of x from 1. It implies f dash x minus f of x is equal to sin x. F dash x minus f of x equal to sin x. Again I will differentiate. F double dash x minus, I am differentiating here. If you want, you can write differentiating on differentiating. Differentiating f double dash x minus f dash x is equal to cos x. Now you can call this equation as 2. From 2 I can write f double dash x. From 2 I can write f dash x is minus sin x plus f of x is equal to cos x from 2. And therefore this implies f double dash x, this is minus fx, this is minus sin x. I will bring it to the right side, sin x plus cos x. So f double dash x minus fx is equal to sin x plus cos x. Range of f double dash x minus f of x is equal to range of sin x plus cos x. This is nothing but minus root 2 to root 2 closed. Between this, minus root 2 means minus 1.414. So number of integers is equal to minus 1.414 to 1.4 minus 1, number of integers 3, minus 1, 0 and 1. So number of integers is 3. The third problem, I will do one more, third one. F R2 closed minus 1 comma infinity be differentiable function, be differentiable such that f of x is equal to x plus integral 0 to x f t dt. Then I will write a few options here. We have to pick which is correct. Gx is equal to x into f of x has only one local maxima, local extremum in R. The second one, Gx is equal to x into fx has more than one local extremums in R. Limit extends to 0. F of x square by 1 minus cos x is equal to number 4. Fx plus x square plus x is equal to 0 has only two distinct real roots in R. We have to verify all these options. We will consider the problem. Now the solution. We will consider the problem. Fx is equal to x plus integral 0 to x ft dt. Now differentiating implies f dash x is equal to, the derivative of x is 1. For this we will apply the Leibniz's formula, f of x into derivative of x is 1. About the lower limit it being 0, it is 0, 1 plus fx. It implies f dash x by 1 plus f of x is equal to 1. Now we will integrate it. Because here from this condition we are not able to identify, or we are not able to get what is fx. So I bring this value on the right hand side to this side. Now integrating, integral f dash x by 1 plus fx dx is equal to integral 1 dx. Now I will call this equation as 1. Whenever it is necessary, I will make use of it. Now integrating. If you put 1 plus fx equal to t, this will become dt. So directly I will write this one. So this is log 1 plus f of x is equal to integral 1 dx x plus c, where c is the arbitrary constant. Now from 1 I will call this as 2. From 1 f of 0 is equal to 0 plus integral 0 to 0 ft dt. Integral 0 to 0 means this is 0, this is 0. F of 0 is 0. Now from 2 into put x is equal to 0. Put x equal to 0. Log 1 plus f of 0 is equal to 0 plus c. F of 0 is 0. This is log 1 is 0. So c is equal to 0. It implies log 1 plus f of x, log 1 plus f of x is equal to x. Implies 1 plus f of x is equal to e to the power of x. Because there is no base mentioned here, we can take e. F of x is equal to e to the power of x minus 1. This is the function f of x. You can call it as 3. Now we will verify the given options. The first option, among the options, the first one, gx is equal to x into f of x. That I mean to say x into e to the power of x minus 1. Now to verify whether it has a local extremum or not, g dash x is equal to this is a differentiating this one, x into e power x plus the x into derivative of this e power x plus e power x minus 1. So this is g dash x. Now here, if you consider this to be 0, suppose g dash x is equal to 0, it implies if you put g dash x equal to 0, now this is x into e to the power of x plus e to the power of x minus 1 equal to 0, implies x equal to 0. If you put x equal to 0, e power 0 is 1, so this is 0, e power 0 is 1, this is x equal to 0. Now you find out g double dash x. G double dash x is differentiating this one, x into e power x, derivative of e power x, plus e power x in the derivative of x, 1, e power x plus the derivative e power x, and this is 0. Now g double dash 0 is equal to, this is x plus 2 into e power x at x equal to 0. E power 0 is 1, this is 2 greater than 0. Implies g has only one local extremum in R. Local extremum in R. The first option is correct. So automatically the second one is wrong. We will verify the third and fourth. We will verify the third and fourth. To verify the third and fourth, I'll cancel this one. Because I'll cancel this one. So this is 2 greater than 0, I'll cancel this one. Now, I'll look into the third bit. What is that? C is equal to, the third one, C. What is C? Limit extends to 0, f of x square by 1 minus cos x. This is limit extends to 0, f of x square. We'll write x square in place of x in fx. This is e power x square minus 1 by 1 minus cos x. F of x square, this is it, cos x, 1 minus cos x. Now I write it as limit extends to 0, e power x square minus 1 by x square by 1 minus cos x by x square. I can write limit here. This is a basic one. Limit extends to 0, e power x minus 1 by x is 1. You can write x square. This is 1. This is also basic. Limit extends to 0, 1 minus cos x by x square, 1 by 2. So this is equal to 2. So the third option is also correct. Now I look into the fourth option. I'll go to the fourth one. What is the fourth option? D. Fx is equal to minus x square minus x. Has only two distinct values. What is fx? That implies e power x minus 1 is equal to minus x square minus x, has only two distinct roots in R. For this, we'll draw the graph. First of all, we'll consider two graphs here. One is e power x minus 1. I'll consider y is equal to e power x minus 1. This is one graph. And the other one is y is equal to minus x square minus x. This is one graph. I'll take the coordinate axis. This is the y-axis and of course this is x-axis. Y equal to minus x square minus x. Take 0, some 1, 2, 3, 4 and so on. Similarly minus 1, minus 2, minus 3 and so on. Now here, I'll draw this graph. Y equal to minus x square minus x. Put x is equal to 0. This is 0. Now, take x is equal to 1, minus 1. If you take x is equal to minus 1, this will become 1 and plus 1, 2. So this is a 1, this is of course 2, 3, 4 and so on. If you take x equal to minus 1, minus 1 square, 1 minus 1 plus 1, 0. So now you take this graph and you take this graph. Okay, at minus 1 what happens? Y is equal to minus 1 whole square and this is minus 1. This is minus 1 plus 1, 0. So I'll draw the graph like this. If you take minus 3 for example, if you take minus 3, what happens? Minus 3. 9 minus 3 whole square minus 3. What is this? Minus, this is 9 plus 3, this is minus 6. Like this. So, fx is equal to x square plus x is equal to 0. That is what we, 1 minute. So, I'll do one thing. I'll write it like this. Minus, this is x plus half whole square. X square plus 2 into x into half. X minus x. Plus 1 by 4. Minus 1 by 4. This is plus 1 by 4. This is a parabola. So it is in the form of y minus 1 by 4 is equal to, or minus of x plus half whole square. You can write here. This is x plus half whole square. This is better. So it is in the form of x minus alpha whole square equal to minus 4a into y minus beta. The graph will be like this. The graph will be something like this. Now I'll take y equal to e power x minus 1. Now e power x minus 1. Put x equal to 0. E power 0, this is 1. Put x equal minus 1. Put x equal minus 1 means 1 by e minus 1. 1 by 2.7 minus 1. This is a negative. So somewhere here. So the curve will be like this. So this will be like this. This will be like this. And the curve will be somewhere like this. And it will go through the origin. So this is y equal to minus x square minus x. This is y equal to e power x minus 1. So it is intersecting at 2 points. Therefore, these two curves are intersecting at 2 distinct points. So now the fourth option is also correct. So except the second one, all the options are correct.